All right, cool. Thanks, Cam.
Thank you. All right, so yeah, I'll go very quickly here. Whoop, so it's up there. So basically, I've been working on a little thought experiment, which is kind of blending two state management frameworks that are used for React together and trying to take the good parts. And so that's MobX, but with kind of a Redux spin. And I'll show you where I got. Okay, so I've given this high-level overview many times before, so I'll kind of gloss over this quickly so I can get to the interesting stuff. But this is what the Redux architecture looks like in its entirety, minus any sort of async stuff that's happening on top of that. So from the components, you have your dumb, vanilla, React stateless components. Typically, they'll be paired with a higher order component using the Redux connect method. And its responsibility is to kind of look up everything it needs to render the DOM component, and additionally wire up any callbacks from the DOM component to create actions that will go into the Redux flow. This will change your state, and your state change will trickle down through your selectors. If you're using a library like reselect, this happens quickly, and it basically memoizes the selectors based on what parts of the state changed. And then the connected components use those selectors to determine whether they should re-render or not. That's a very fast overview of Redux, so I'm sorry if you're not familiar, but I'll continue. So what's good about this is that it's very explicit. Every step in this kind of flow is very deliberate, and it's controlled by you. When you're using Redux, you're not really ever importing things from its API, with the exception of the connect method, which is itself a very simple wrapping component that just subscribes to state changes, looks up some stuff on your global state. But otherwise, you're just writing vanilla JavaScript, and you're kind of adhering to this pattern. And so that's very simple, it's very deliberate, and it's easy to trace. Probably the best part of Redux to me, though, which is commonly overlooked, is this separation between your dumb and smart components. So the idea that you have these dumb components that just do the rendering, they take just simple flat props, and they're wrapped in a smart component that takes minimal information, usually an ID or nothing at all, and they kind of know how to grab all of the things that they need to render their dumb component. And so this is really good for a couple of reasons. It's awesome for testing. I can test my dumb components without having to mock out the Redux world. I can write storybook stories with my dumb components, and if I decide to change my state management framework the next week to Relay or to MobX, I can do that without having to change my dumb components at all. So I've kept that rendering logic decoupled from my state framework. What's bad about this? Well, there's a lot of boilerplate. If you write Redux a lot, you know that there's a lot of boilerplate. Hooking up something as simple as clicking a counter button and having that increment a number on your screen can involve writing the connected component, writing an action type, writing an action creator, writing the reducer for that, and then writing the selector that gets the count out of the state. That's 5 places to increment a counter, which it's heavy, but again, it's explicit. And so another disadvantage of Redux is that every state change, no matter what the change was, will at a minimum need to rerun the map state to props on all of your connected components. So you can make this faster by using something like reselect so that you can memoize this step. But conceptually, your performance is still going to scale based on the number of connected components in your component hierarchy. And even if that happens quickly, in principle, it just feels wrong. Like a connected component should be able to know what state has changed and whether or not it should be interested in that state change. So if there was a mechanism that allowed you to do that, that would be really good. And there is, and it's called MobX. And so I've given a talk on MobX before. There is a recording of that FEF talk. I'm not going to dive too much into the library because I kind of want to get to what I've kind of bolted on top of MobX. But basically, you could think of it like spreadsheets. It gives you 3 primitives or concepts that you can work with. This isn't like Redux. I'm actually importing API functionality from MobX. It's a library. It's an abstraction like React. And so there's a bit of magic involved in that. But basically, the 3 concepts are you have an observable. And those are interesting because of the second 2 concepts. The first being a computed property. So you can think of this kind of like a selector in that it's a way of calculating a new value or a transformation based on your state, if your state lives in the observables. And basically what MobX is going to do is it's going to record all of the pieces of observable data that were needed for that computed property. And anytime those observable pieces of data change, it's going to automatically recompute your value for you. So the analogy here is a spreadsheet where I might have like a couple of columns of source data, and I have a third column that has a formula that's based on the first 2 columns. I would expect as a user that when I update one of the values in my source columns, my computed column just updates automatically. And that's what MobX does for you. So the third concept is that of an observer. It's similar to a computed property in that it's a function that touches some pieces of observable state. But the difference is that it's a side-effecting function, and MobX will rerun this side-effecting function anytime the observables it cares about change. So a simple example of this is if I have, 3 pieces of observable data and I write an observer function that just logs out the 3 pieces of observable data, if I change any of those 3 things, the console log will be rerun for me automatically. And so when you pair this with React and you imagine a component being a side-effecting function and my props being observable data, MobX is going to automatically re-render components that should re-render based on the data that changed, and it's going to do that without me having to worry about it. It will do it for free. So my problems with MobX is that it is incredibly unopinionated. The library kind of just gives you these primitives, but the documentation don't really point to a way to like structure and scale like a large application. And so kind of a lot of the docs just point to the simplest possible use case, and that's that you will make this observable store. And a store is like a Java class in that it's going to hold some pieces of state. In this case, they're going to be observable pieces of state, but it's additionally going to hold the methods or the actions that mutate this state in place. And so it's kind of like this fat model that contains both state and methods. And so the simple example that's given in the documentation is you just have this big store and you just pass it around as a prop. And so components will directly take this store as a prop and use the observable data and call the methods on that store directly. And so what's good about this? Well, it's incredibly simple. You compare this to that diagram and it's like, there's only really 2 concepts here. You have observer components and some observable state. So there's no boilerplate, and you get the minimal re-renders out of the box, thanks to MobX. So what's bad about this? You're leaning on magic, which I think is okay. We all lean on React's magic. We like that abstraction. So if it's a good abstraction, I think the magic is okay. But the thing I don't like about this recommended approach is that we've lost our dumb and smart component separation. And so that has a couple of consequences. So we kind of leak these observer decorators all over our dumb components that should only care about rendering props. And this kind of couples our components to MobX. So I've lost that flexibility to change my state management framework in the future. If I want to switch back to Redux or switch to Relay or something like that, it becomes harder to untangle my components from knowing about observable data and knowing that they themselves are observers. And also, if you follow the recommended approach, you kind of can fall into some of the traps that exist with just vanilla React. And that's that you'll end up passing props down your component hierarchy that components won't necessarily need for their rendering, but some child in the distant, deep parts of the hierarchy will care. And so that makes it very hard to shift things around in your component hierarchy because you have these contracts between your parents and children that wouldn't usually exist if you had smart component wrappers. And so how can we solve this? So this is the architecture that I've kind of been playing with. It's like a blend of the two. So basically, we have our dumb vanilla React components. They're not marked as observers. They have no knowledge of MobX. We wrap them in a higher order component that's doing exactly what a Redux connected component would do. It's looking up anything it needs from the store, and it's wiring up any callbacks from the dumb component so that it will call the actions on my MobX store. And I've kind of replaced the idea of selectors with this mapping function. It is like a blend between map state to props, map dispatch to props, and the selectors as well, but you don't need to break them down because there's no immutable data in MobX, which I'll get onto a little bit later. And so I can directly wire my callbacks to just call actions on my store, and that will just mutate things in place. And I'll show you how this looks in some code in a second. So what's good about this? It's still simple. There's still no boilerplate. I still get my minimal re-renders out of the box. I've maintained my smart and dumb component separation, so there's no need for the observer decorator. There's also no need for selectors because MobX is smart enough to track that mapping function. So if my mapping function is being rerun, it's because MobX knows ahead of time that it should rerun that function. It knows that something in there has changed and that component should be re-rendered. And yeah, the connected components, that kind of leads on to the fact that the connected components will only reconcile when they should. So it's not like Redux where if I change the state, I need to look at every connected component. I'll only look at the ones that matter when the state changes, which is really powerful. So what's bad about this? Well, it's still magic. And what's worse is that it's not even standard MobX anymore. It's like a unique flavor of MobX. So like good luck finding help or documentation on this pattern because it doesn't really exist yet, I don't think. And so enough talking, I'll show you what the code looks like. So we'll start at the store. So if you haven't seen a MobX store before, this is kind of what it looks like. I'll make that a little bit bigger. So I'm using TypeScript. By the way, TypeScript works really well with MobX because MobX is written in TypeScript and you're not using like string comparisons or switch statements like you are in Redux reducers. You're using instances of classes that have state and data, that have state and methods on them. And that's something that TypeScript supports very well. So you get very easy type coverage. But basically, I have this counters store. It has a single observable property, which is an array of counter objects. These are denormalized, which is another difference to Redux. For a bunch of reasons, MobX prefers to have a denormalized source of truth. This is okay, though, in practice, because usually your server payloads are going to be denormalized. So MobX is fine with you just dumping that server payload into your store. And these two computed properties are kind of the core of what lets me maintain my smart and dumb component separation. So I have one computed property that's going to return the array of counter IDs, and I have another computed property that's going to return a map that's indexed the counters by their IDs. So at this point, I'll just show you what the actual app looks like, because it might make it a little bit clearer. But this is like the poor man's to-do MVC in that it basically has the same requirements. I have entities that have their own unique state and the ability to kind of add more entities at runtime. So this is like a good test as to whether a particular architecture is going to scale. So I have two actions, and these are just methods on my store. One is the add counter action, so that's the one that adds a new counter. And you can see that I'm literally just pushing a new counter object onto my array. There's no immutable library here. There's no dispatching an action and reducing it or anything like that. I'm just mutating my array in place. I have a second action that is incrementing a counter by 1. And you'll see that I'm using my computed by ID property in the action here, and that's fine. I can always just assume that this by ID map is kept up to date because that's the magic of MobX. That's what it will do for me. And so that's the store. So we'll go through the kind of top down through the component hierarchy. You'll see this is like the normal boilerplate of setting up a React application. So I'm using a provider. And this is just like the Redux provider. It's the MobX provider. And so basically, it's just going to put all of my MobX stores onto the React context so that I can grab them off later in a higher order component. And then I'm rendering my top component, which is the counter list. You'll notice that I'm passing it no props. And that's because counter list here is a smart component, and it's going to look up everything that it needs to render its dumb variant. So the counter list, that's probably important. Nice. So the counter list, we'll just look at the render method. It takes an array of counter IDs. It takes an odd add counter callback. We're just mapping over the IDs and rendering a counter. And we're giving each counter an ID, and that's it, because that counter itself is a smart component. It's going to look up what it needs to render itself. And this is kind of the important part. So this is using the inject method from MobX in a way that I'm almost positive it wasn't intended to be used. But basically, you can treat it like the React Redux connect method in that it's going to take a mapping function that will take as an argument all of your MobX stores. And these are the stores that you gave to the provider. And it's kind of up to you to return the dumb components props. And so in one place, I can wire up both my counter IDs. And so this is that computed property of the counter's IDs that I showed you on the store. But in the same function, I'm also wiring up my callbacks to just call a function that exists on the store as well. And so that's the on add counter here is just going to be wired up to this add counter action that was on my store. And so the final piece is the counter itself. It takes two props, the on-click and the value. It's a plus button with a click handler, and it's the value that it's going to render. And so this inject method is a little bit different because I actually care about the ID that my parent gave me, and I can grab that from own props. Again, this is identical to Redux Connect in that I have access to the props that the parent gave me, and that's all I need. So we look at the value here. I'm using my by-ID computed property again to grab the counter for that particular ID, and I'm grabbing its count. And then for my on-click, I am wiring that up to a function that will call increment with the ID of the counter that my parent gave me as well. And so that's what lets me just give an ID to this counter. It's going to grab everything it needs off my MobX stores as if it was like a Redux smart component as well. And that's basically it in terms of the code. There is no selectors, no action creators, no action types, no dispatch pipeline. And some of those things might be bad, like you lose a bit of control by using this approach. But I think it's pretty good, and I'm like keen to see how it scales with a larger application. So I have a couple of repos up. I didn't show you the Redux one, but I've implemented the exact same app in Redux, so you can kind of do a side-by-side comparison. The important part is that the DOM components are identical, and so that means that theoretically you could have swapped from one to the other without having to rewrite your components, which is great. But yeah, I also have the MobX one there as well. So sorry, that was very fast. Does anyone have any questions about the approach?
Yeah, sadly we don't have long, so it'll have to be just a few.
Hi. Do you use any tooling around MobX?
As in like dev tools?
Yeah.
Yeah, so MobX has some really good dev tools. That's this little panel up here. And so it does a couple of things. It can highlight components that need to re-render. And this is because it's using MobX's little dependency graph. It knows, oh, I changed that observable property. That particular component needs to re-render. And what's even cooler is that you can see the dependencies of a particular component's rendering. And so these are the observable properties that exist on my store that if I mutate them will cause an individual counter to re-render. And similarly, I can look at the dependencies for the entire counter list as well, and you can see that it's just depending on the IDs. It doesn't care about the counts of the individual counters or anything like that. But yeah, the dev tools are really nice. And also, as I said, like pairing this with TypeScript means that you just get like full code completion everywhere. So if I like typoed when I'm using my store, I'll get compile time warnings that, you know, I'm not using the store correctly, which would make refactorings very easy.
Also, have you had a chance to check out the new library that's been making, I guess, some buzz lately? Is MobX State 3?
Yeah, so I looked at that. It doesn't quite have the smart and dumb separation that I wanted. It gives you like a more opinionated way to define MobX models. But I think in principle, you're still kind of passing a big blob of props down your component hierarchy. And depending on your app, this is fine. Like a lot of apps, your state structure can kind of map to your component hierarchy quite easily. But I think there are cases where that doesn't happen. And so if you want a one-size-fits-all, I think the smart and dumb approach is more flexible for that.
Cool. Thanks. We'll have to leave it there because we're out of time. But thanks so much.
Thank you.
That was amazing. I'm like actually really keen to go try it out.